In this workshop series, we'll have an opportunity to follow a group of children beginning in first grade and continuing through graduation from high school. Let's start by looking at very young children, before they begin their formal education.
When kids are playing with blocks, they will line up a number of blocks in parallel, and they'll be all blocks the same size. They will be very careful to make a square. They'll be very careful that the right angles are correct. So we think when they're doing activities like this, they are learning some very fundamental geometric ideas.
Some of these students, now in their senior year in high school, are part of a focus group of children whose mathematical thinking has been followed in depth year after year for 12 years.
I began my career as a mathematics teacher. I taught high school for several years and then taught mathematics at the two-year college level for another 6 or 7 years. Then I moved to mathematics education at Rutgers University and discovered that I really didn't know about little children. My own work was with older students, high school students and college-age students, and I had to learn more. So I began to go to classrooms and work in classrooms with younger students. When I visited Harding Elementary School in Kenilworth in 1985, I really had not fully realized how rigid the math instruction was. It was very rote, and it was sort of sad because the principal at that time was so aware that the students who moved on to the high school, their very best students, were barely making C's in mathematics. And he was very concerned. This is really before standards. This is before the reform movement in mathematics. The curriculum was very rigid, very atomistic, and very much computation-driven. And there was really no attempt to develop understanding on the part of those students.
In 1989, just as small, reasonably priced video cameras were becoming available to researchers, Carolyn's group began to videotape the Kenilworth students working on mathematical activities. These activities, which were separate from the standard school curriculum, were designed to reveal the students' mathematical thinking. The Rutgers team has collected over 2,000 videotapes following the same group of students, from first grade through high school.
6 times 3 is 18.
This is the longest study about the long-term development of mathematical ideas ever conducted.